Welcome to The Curious Developer. I'm Jesper from KDAB, and you just landed in the middle of a series on AI-driven software development. We've been looking at the tools and we've been discussing different models, but one thing that always is not super clear to me is the actual statistics behind the scenes. So I would like to understand that a bit better, and to help me with that, I still have Jan Margo with me on the show. Welcome and good morning, Jan.
Hi Jesper, good morning.
Okay, Jan, while you get your first cup of coffee or tea or beer or whatever you drink in the morning, let me add just a comment to my viewers here. I admit we did record the first 4 episodes in one go, so it was in one day. So even though I said good morning every morning, every episode, we did actually not wake up 4 times with the same clothing on. So there we are.
Now that you have that off your chest, how did you sleep this night? Because the last nights you had, I think, one good night and then a few nights where you were staying up all night figuring stuff out. So how did it go now?
Actually, I slept like a baby, like waking up every 5 minutes screaming, So now I actually slept pretty well. Even though we talked about my master thesis, which usually when I do stuff like that brings in pages from my memory, just like a computer. And on those pages there are when I was thinner and I was doing jiu-jitsu and I had other girlfriends, not at the same time, mind you, than my wife today, I still slept very well and none of those came back. So shall we get started? Statistics?
Sure.
Let me tell you a bit about my master thesis. So on your screen, because I'm not sharing my screen, so on your screen, we now see a piece of code that is not from my master thesis. This is from recent code. But what I did in my master thesis was that I was trying to extract test cases from a language called VDMSL. It still exists, but nobody knows about it anymore. It's a very high-level language, and I wanted to extract test cases for that language. So I would pass the AST of that language, and I would try to see if I could generate a full set of test cases. And that did not go very well. As soon as I hit recursion, I would generate a 2 to the power of n, if it was a simple if then if else recursion, and that gave me enormous amount of test cases. So that just didn't go much, but at least I got my master's degree. But then now with AI, one of the things that is said that you can do is to extract test cases. So I tried on this code that we're looking at here, and if you look at it, you can see that there is, I think I counted 5 different returns here in this code. So there's 5 different ways that you can go through this code, and if something is true or if something is not true, but something else is true, then you end up somewhere in this code path and have a return there. I tried extracting that with the help of AI. And I got, 1, 2, 3, 4, 5 returns. I got 4 test cases out of it. It forgot one of the branches. I mean, how stupid can it be? Everybody can see that this is super easy to see that either this is true or it's not true, and then you go down there. Why couldn't it even do that right?
Okay, so when I think about AI models or LLMs, then the imagination that I have of how they work on a very general level is that they look at some piece of input and then they predict an output. And in most cases that people interact with them at the moment, this is usually chats, right? So you have some chat conversation with past messages, and this is your input to the LLM, and then you would ask the LLM to predict what would the chat conversation continue. And that is what we generally consider the output of the LLM or the reply of the LLM to the user. And it works similarly when you paste this code into a chat interface and then you say extract some test cases. And then the LLM will make a prediction of what seems likely how this text would continue. And so I'm not going to say that this is exactly how they work, but this is how I think about it. The internal workings of LLMs are not super well, like they are researched, but we don't know on every level how decisions are made within an LLM. So the way that I'm thinking about is how I try to reason and understand what I can expect and what I cannot expect. And it turns out that you can apparently predict and generalize natural language and computer code in a way that these predictions make a lot of sense for people. So if you have enough input, you can produce a stream of text that makes sense, even though maybe the LLM doesn't completely understand in the way that humans understand what's going on there. So if you now look at this code and then also use the words generate test cases from this, the statistical continuation of this, or one statistical continuation of this, would extract a few test cases, but it's also likely that maybe one of the test cases that you should have will be missed. And this is what's going on here, probably.
Yeah, it reminds me of that old child game or drunk game, depending on your age, where you sit in a circle and the first person say a word, and then the next person needs to continue that word, and the third person continue those two words. So I was at a, and then continue on and just see what story comes out of that. That's really what LLM does. They just go to parties and do party games, I guess.
So I think there are a few versions of this game, so I just want to make sure I'm understanding here. So I always only know the exact next previous word that has been said, right? So I don't know all of the previous words when I do this. Is that correct?
No, in my version of the game, you sit in a circle and everybody know the text up until that point, which is actually what the LLM does, right?
Yeah,
the statistics is based on the sentence so far. I just find it, I mean, I can understand that for natural spoken languages. That makes a lot of sense, that when I say something, then there is a huge percentage likelihood that I'll continue my message with. And then you would guess whatever. Next word here.
Oh, I won't.
Right? Or you won't. But there's a chance that you would. But that seems still far stretched for me with LLMs. I mean, extract test cases. A test case is so much more an important word, at least initially in that sentence, than the whole piece of code.
So you mean in the sense that, so how does an LLM decide what is the question that is being asked and in which direction it should make the prediction? Is that what you're asking me?
Yeah.
So without going into all of the details of how these models are built, they are structured in a way that they can assign basically scores to parts of the text and think that this, or develop a concept of what pieces of the text seem to be important and what not. And this is based on the training data that they receive when they are being trained. And especially when you fine-tune models for a chat use case and for programming use cases, you will also include exactly this. You will include pieces of code and then ask questions to it, but then also have an expectation of what the LLM will generate, like the exact conversation of how it should continue. And then you train the LLM to produce this continuation, that exact continuation that you're expecting. And from that, you can fine-tune the LLM to focus on the code as the thing to work with and the question as the thing that is supposed to be replied to in the prediction that is being made.
Okay. And I'd like to take this one step further. We are now at a time and place in the history of the world where it will forget one of those branches and everything is cool. But we also, in the preparation for this interview here, talked about your vision of tools in the future that will make sure that it extracts all of the test cases. Maybe you can tell the rest of the world about this conversation.
Well, I don't want to say that this is particularly my vision. It's just where I was thinking where this is going to head, and it's still heading in that direction. You see a lot of tools that are built like that. So I just don't want to claim credit for that idea. It's just the way that I phrased it here. So if you look at, for example, the different extensions that we have available in QCreator, or you look at Visual Studio Code, which is a more common coding platform that has also a lot of AI-based extensions, then the extensions often differ less in which particular model they use. So do they use an OpenAI model? Which one? Do they use a model from Anthropic or from Google? That question usually doesn't matter that much because the models, the extensions usually use roughly the same models. But the extensions differ in what kind of context do they extract from the code base and maybe from other code bases or from the memory of interacting with you in the past, and then put all of that together as an input to the LLM. So to make this more specific, we have looked at the Qt AI assistant plugin in QCreator, and that, from how I understood how it works, often extracts the previous and like the context of the code in the same file, but it would, for example, not look at different files across your project. If we now look at Copilot, the early extension of Copilot, then one of the key ingredients of the Copilot extension was that it was looking at different pieces of your code that looked similar, or that file names that seemed to match, or other open files in your editor. And it was using those to also create context that it would, together with the specific code that you were working on, give to the LLM in order to ask for predictions or for actions. And this made Copilot use a lot more context that very likely was the context that you as a developer also had in mind when you were developing. And that would improve the quality of your predictions in Copilot. And so this is how I'm currently thinking about the world that we see with LLMs, is that we will probably see...
Can I just interrupt you there?
Yeah, sure.
Yeah, because that makes me wonder, is that why tools like Copilot... So let me give you an experience here. I've written this algorithm library called KDAB algorithms that you can see on Qt and more. Oh man, I'm good at bringing in those. It is basically an algorithm just like std find, but I have KDAB algorithm find, and there are slightly different. I noticed when I started using GitHub Copilot that it actually was suggesting KDAB algorithm find over std find whenever there was something that smelled like, hey, I need to do, which puzzled me a lot because obviously in its foundational training, there isn't all that many use cases, unfortunately yet, of KDAB algorithm out on the internet that would be what it would suggest initially. But what you're saying is that GitHub Copilot actually were able to go and sniff my code base at a larger scale and figure out that this dude, whenever he wants to find something, he wants to use KDAB algorithm find over std find.
Yeah, with maybe the additional notion of in that code base that you were working on, right? So if you would switch to another code base by a customer, for example, that are not using your library yet, then the Copilot would be working with the information that is available in that code base, and that means that it would not suggest KDAB algorithms find. Yeah.
Okay. You may continue if you remember where you were.
Okay. So what we're seeing with these extensions is, and this is, for example, Copilot recently introduced agent mode, where Copilot uses tools. And by tools, I mean it uses command line tools and it uses search tools. And there is a whole protocol built around supplying tools to an LLM or to an agent, so that the agent can use tools to get structured information and then use this structured information to produce human language output or translate that into code changes. So what we're seeing more and more, and I think this is something we will be seeing for quite a while, is that we combine LLMs with tools that do structured analysis. So coming back to your master's thesis, you said it wasn't super successful, but if it had been successful and you had developed a tool that would reliably, for many different code bases with different complexity, extract test cases, then you could write an adaptation so that it's available as a tool with coding agents, with LLM-based coding agents. And the agent could then, at some point in time, in the interaction, decide that, oh, this would be a good usage of that tool. So it would query the tool and then take the output of the tool to actually generate a diff and generate replies to the user. And that way you would get a combination of what LLMs are great with, that is mixing structured and unstructured input and interacting with humans, and some level of reasoning to whatever degree that works and is reliable, in combination with already developed and algorithmic and tested tools. And this together could come to very helpful development tools, also for this use case, for example.
So in a less weird world where I was successful in my master thesis, those tools, they might do stuff like extract test cases for this, run the actual test with code coverage turned on, figure out which branches wasn't hit, go back to the LLM, say, can you extract me a test case that hit this exact piece of or this line of code, and then it would give it a second shot. Is that correct understood?
Well, that's something I would imagine you could create, yes. So this will take a while, and my assumption is that people that develop agents at the moment, they are trying to provide quick user feedback. So if this is a tool that's longer running, that might come in as a problem to whoever develops the agents. But in principle, this is something you could try to develop. I do want to point out that automatic code running by AI agents or by these plugins is something that can be quite dangerous, because you don't really know what code they generate. So they might try to extract code or delete files or whatever else could be going on. There's also a whole set of literature on how do you get an LLM that is supposed to not create harmful code to actually create harmful code. So my expectation is that there will be continuous checks that you actually need to agree on, yes, I want to run this code, I want to run this test, and so forth. But building tools like that is, I think, very much in the future and actually already happening to some degree.
And this is the time for a small announcement or advertisement for Qt widgets and more, because if you're on Linux, I would suggest before you start using these agents that you go to this, I don't know which side of the screen is showing up, this URL or this episode from Qt widgets and more, where I back up every 10 minutes. Because I had an incident where I am using Git to check things in regularly, but sometimes you work on something for an hour, and I had an incident where my editor just garbaged my file. So I guess the same thing could happen in the future of LLMs. Yeah, did we cover everything in this episode, you know?
Yeah, we have covered what I would have put in here. Yeah.
Excellent. Well, thank you very much. The next episode, because we are far from done yet, but the next and last episode with Jan, unfortunately, is gonna be on other tools than just Qt Creator, and look at what they provide. Thank you, Jan.
Yeah, thank you.
And until next time.
See you soon.
Have a great time.